Texas Math Mundo audience. Today we have an addition to our instructional series. The topic is the binomial theorem. Before we get started, let me quickly ask that if you enjoy this content, that you please hit the subscription button and the notification bell, that you leave a comment below, and you smash that like button. Okay, without further ado, the binomial theorem, right ahead. Okay, we start off with a statement of the theorem. And above here, it's succinctly stated using summation notation. I sometimes like to call this the binomial expansion theorem because that is precisely what it deals with, expanding a binomial. And one way to state it using summation notation is from the index k equals 0 to n of n choose k, a raised to the k, b raised to n minus k. I think it is often helpful to expand to watch a few of the terms. Now please note on this expansion below, they interchange the a and the b terms. It's still very much equivalent. It is equivalent. So if you start writing down a few terms, it's n choose 0, a raised to the difference, b raised to the bottom, n choose 1, a raised to the difference, b to the bottom, n choose 2, a raised to the difference, b to the bottom, all the way to n choose n, a to the difference, b to the bottom. Remember that pattern is going to prove useful. You should note that if you have a binomial raised to the nth power, there are n plus 1 terms because you start off with n choose 0 all the way to n choose n for a total of n plus 1 terms. I should also note that n choose k, that notation, is for combinations. The number of ways you can combine n objects taking k at a time. You often learn this in probability, maybe as a section in statistics class, and that is equal to n factorial, n minus k factorial, k factorial. Also, let's say you have 5 objects and you take 3. Well, every time you take 3, you're also leaving behind 2. So a very interesting identity, it often proves helpful, is that n choose k is equal to n choose n minus k. Because if you pick k objects, you're leaving n minus k objects behind. So you're actually picking them both ways. All right, so that's a statement of the theorem. And now I want to illustrate how it's related to Pascal's triangle. All right, I did want to take a moment to relate the expansion of a binomial to Pascal's triangle. It's a very popular result. So if you have a binomial raised to the 0, or anything raised to 0 is 1. And then you have a binomial raised to the first. If you look at it, it becomes a plus b. If you look at the coefficients, they're just the next line. If you then raise a binomial or expand a binomial to the second power, and you look at the coefficients, it relates to the next line of Pascal's triangle, and so forth. And so this is a very interesting relationship. Also note you can rewrite this using combinations. 0 choose 0. Next line would be 1 choose 0, 1 choose 1. Next line would be 2 choose 0, 2 choose 1, 2 choose 2. And so we can Pascal's triangle can be rewritten using combinations. That's oftentimes why these combinations are actually called binomial coefficients. It's a very beautiful relationship. I just thought I'd mention that explicitly. Now let's go on to solve some problems. All right, the first problem we're going to look at is from the year 2016, the UIL B release, number 36. And the statement says, in the binomial expansion of 2x plus 5 raised to the 6, the coefficient of the fourth term is. So please note that you want the fourth term. The binomial expansion starts off with like n choose 0, in this case 6 choose 0. So the fourth term would be 6 choose 3. Then remember it's the first term raised to their difference, which is 3, and the last term, 5, raised to the bottom. So 6 choose 3 is not too hard to calculate by hand. 6 factorial, 3 factorial, 3 factorial. And so it's 6 times 5, it actually equals 20. I'm going to show you right now how to use your nspire. In fact, let me do that right now. If you take your nspire, the way you can get your factorial is you go to menu. The way you can get your combinations. Go to menu, and then you can go to probability, and then you can go to combinations. And then in this case, we wanted 6 choose 3, so it's 6, comma 3, and we push enter, and it's 20. All right, so that was that, so it's equal to 20. And then 2x cubed will become 8x cubed. And then 5 cubed is equal to 125. And so we multiply 20 times 8 to 1 times 125 to get our answer. So 20 times 8 times 125, 20 times 8 times 125, and our answer is 20,000. So the answer is C. Good. Let's go on to the next. Okay, the next problem comes from the year 2018, the UIL A release number 21. It says in the expansion of 3x minus 2 raised to the fifth, the sum of the coefficients of the third and fourth term is. And so applying the binomial expansion theorem, the third term, keep in mind, is 5 choose 2 because it starts with 5 choose 0. So 5 choose 2, the first one raised to their difference, the bottom one, the second one raised to the bottom. And that's the third term. The fourth term is going to be 5 choose 3. And keep in mind that 5 choose 2 is equal to 5 choose 3. Every time you pick two objects, you're leaving three objects behind. The first term raised to their difference. The second term raised to the bottom. And so once we find those coefficients, we can find the sum. 5 choose 2 would be 5 factorial, 2 factorial, 3 factorial. So it's 5 times 4 divided by 2 is 10. So it's 10. And 3x cubed would be 27x cubed times 4 for this term. Over here, we know that 5 choose 2 is the same as 5 choose 3. So again, we have 10 times 3x squared would be 9x squared. And then you have a negative 8. So 10 times 27 times 4. So 10 times 27 times 4, and we end up with 1080 there for this coefficient. And over here, 10 times 9 times a negative 8. So 10 times 9 is 90, times a negative 8 is a negative 720. So if we add up 1080 and negative 720, we should get our answer. So, oops. Minus 720, and we get 360 as our coefficient. 360 is our coefficient. B. All right, and so that's how that's done. Let's go on to the next problem. All right, our next problem is from 2017, the UIL A release number 6. And this is an interesting application. It says let p and q be the roots of 2x squared plus 3x minus 5 equals 0. Find p cubed plus 3p squared q plus 3pq squared plus q3. So you should recognize this as in a binomial expansion to the third. This is p plus q raised to the third. But p and q are roots, so this is an expansion of the sum of roots. This is the sum of roots to the third. Well, Vieta's formulas, which I have a video on by the way, tell you that the sum of the roots is negative b over a. So it's negative 3 over 2. That's without even knowing the roots. You just know the sum of the roots. Raised to the third. So it's a negative 27 over 8. And 8 goes into 27 3 times. 24 with 3 left over. So 3/8. And that's equal to a negative 3 point. And 375. 375. And so there goes your answer, E. And so that's a quick application of the binomial expansion theorem. All right, so now it's time for you to do some problems. Okay, so now I'd like you to try your hand at these problems and applying the binomial expansion theorem. So what I'm going to do is I'm going to read the problem. So this is from 2018, the district test number 16. And the statement of the problem is, in the expansion of the quantity 2x plus 1 raised to the 6th, the sum of the coefficients of the second term, the third term, the fifth term, and the sixth term is. So if you please pause your screen right about now, I'm going to show my work in super fast motion, and let's see if your work agrees with mine, and this is an opportunity for you to apply what you have learned. Okay, pause the screen. All right, did you come up with the answer? The work kind of roughly shown is there. And let's go to the next one. All right, the final problem I'd like to attempt is from 2016, the regional UIL test number 38. And the statement of the problem is, Let p and q be the roots again of this quadratic. 2x squared plus 7x minus 4 equals 0. Find p raised to the cubed plus 3p squared times q plus 3pq squared plus q to the third. And so pause your videos at this point. I'll show the work, although this is a brief one. So pause your videos right about now, and let me show the work. And so your answer is C. You recognize that you want the sum of the roots expanded to the third power, and so by Vieta's formula, the sum of the roots is negative b over a, and that's how you get it. Good, I hope you learned something, and that's my instruction for today. Okay, Texas Math Mundo audience, that's my treatment of the binomial expansion theorem. I hope you learned something, and I hope it helps you in your competitive endeavors. Let me take a quick moment and ask that if you enjoy my content, that you hit the subscription button and the notification bell, that you leave a comment below, and you smash that like button. I got plenty of wonderful things in store for this channel, and I truly appreciate your support. Thank you very much. Farewell. Farewell.